Let's observe some objects that sink and float, like a jar of sand and a jar of cotton. What do you think is going to happen when I put the sand and cotton jar in water? Will they sink or float? Let's find out. If you guessed that the sand would sink and the cotton would float, you were correct. But why does this happen? To get a better idea, we need to take a closer look at the sand and cotton jars. When we zoom in on the sand, we can see that the jar is packed full. However, when we zoom in on the cotton jar, we can see the jar is not as packed. Can you see the spaces between the cotton balls? We're observing something called density. Density is how tightly packed molecules or atoms are in a substance. You've seen density before if you've packed a bag for a trip. If you're going on a short trip and you don't pack that many things, your bag is not going to be very dense. If you pack for a longer trip, you'll need to bring more items and your bag is going to be more densely packed. Now that we know about density, let's look at the jars again. Which jar do you think is more dense, the sand jar or the cotton jar? The sand jar is more dense, which is why it sunk. When we put the sand jar in the water, it sunk because the water molecules are less dense than the molecules in the sand jar. Since the water molecules aren't packed close enough to hold the sand jar up, the sand jar pushes right past them and sinks. Meanwhile, the molecules in the cotton jar are less dense than the water, so the little water molecules can hold up the cotton jar, making the jar float. What does all this have to do with lava lamps? Well, we know the blobs in a lava lamp are sinking and floating. But how can a lava blob float 1 second and sink the next? When a lava blob is at the bottom of a lava lamp, it is close to a hot light bulb that heats up the lava blob. When the blob gets hot, its molecules expand and it gets less dense. What do things do when they are less dense than their surroundings? They float. The lava blob that is less dense floats up to the top of the lava lamp and hangs out at the top. But now the blob is far away from the hot light bulb, so it starts to cool down. When it cools, all its molecules get closer together, and the blob gets dense again. Once the molecules in the blob are more dense than their surroundings, the blob sinks and the cycle continues.